Hello everyone, I'm delighted to be here to share our research. My research topic is tangible diffusion, exploring artwork generation via tangible elements and AI generative model in art and design education. First, let's discuss the background of this research. Generative art is an emerging field that utilizes artificial intelligence algorithms to automatically create digital artwork. Now, it is also gradually applied in the field of education. Stable Diffusion is an open-source program that can create generative art, primarily generating high-quality artworks through text input. Through a web-based Stable Diffusion UI, non-expert users can easily create a diverse set of high-quality images with thematic coherence. LoRa's unique low-rank autoregressive method enables it to generate different styles of images with fewer training examples. At the same time, LoRa models are easy to access on the website or train yourself as needed. Prompt words and the LoRa model cannot precisely control the content of images. ControlNet works by providing a set of high-level controls that can be used to manipulate the generated images, such as changing the pose or orientation of the object, adding or removing objects. However, generative art is not conducive to children's direct operation because many parameters need to be adjusted before it can be used, increasing children's learning cost. Using tangible interaction to generate art images might make it easier for children to engage with generative art. This paper proposes a pipeline for using tangible elements to generate artwork. Teachers are responsible for designing prompts and selecting or training LoRa models that are appropriate for the chosen theme. Students are responsible for building with the tangible elements and taking pictures of their creations. The pictures are then used in combination with ControlNet to generate high customized and expressive artwork automatically. First, teachers initiate the pipeline by designing prompts that align with the educational objectives and the chosen theme, such as landscape or architecture. Second, choose or training a LoRa model that fits the theme. In this step, teachers carefully choose or design tangible elements that correspond to the theme and prompts. To alleviate the challenges associated with generating high-quality artworks, teachers adjust the ControlNet parameters. And then it's the students' turn to get hands-on, creating models with the physical models provided by their teachers. After they have put their pieces together to make their artwork, students snap pictures of what they've made using either digital cameras or their phones. They use these photos as a starting point on the teacher's computer system to kick off the art-making process automatically. The experiments demonstrate that the proposed pipeline can be applied to various scenarios, using either of the sheaf or carefully designed tangible elements. Next is an experiment involving building structures with Jenga blocks, followed by generating architectural models with specific themes. We invited different children to build a museum using blocks, and after completion, they photographed and uploaded it to Stable Diffusion to generate digital images of the museum. Then, we assisted the children in changing the prompt from modern museum to shopping mall to observe how easily the creations could be transformed into another theme with the aid of AI generative models. Another experiment involved building blocks for Chinese classical poetry, which is pivotal in language education in China, but challenging due to its unique grammatical structures. Unlike another forms of poetry, such as lyrical poetry, the landscape poetry contains concrete imagery in its content, such as mountains and rivers, making it suitable for materialization through physical construction. Identify the concrete imagery in the poem, then construct it using geometric model. Combine these two from mountains, trees, balls, and cube with wave surfaces to represent water, waterfalls, and so on. In this experiment, the building models were specifically designed for creating landscape scenes, with an emphasis on flexibility, modularity, and stability. These blocks are mainly composed of cubes, cylinders, and triangles with multiple relationships. In the following experiment, children were asked to construct a scene based on the poem Cataract on Mountain Lu, which primarily described the scenery of the waterfall at Mountain Lu. These are different children's models of this poem. They chose two lower models to try different styles. In addition, children are also encouraged to take pictures of the physical scene from a different perspective to observe corresponding changes in the generated images. Future work might include integrating additional algorithms to refine the results, such as using reference control to ensure consistency in digital image content when modifying physical scenes. Thank you very much for your patience in listening to my presentation.